Hi, hello, good day to all my Form 4 students. Today we are here to start on new chapter called acid, bases and salts. So this video is on part 1. Okay, so we are going to do part 1 for this chapter. This is actually chapter 6 for your DSKP Form 4 syllabus chemistry. So let's start. So we are going to, in this lesson, we are going to cover on the meaning of acid, what are the attributes of acid, such as definition, physical properties, and basicity. And for base, we will be covering two, which are base and alkaline. Teacher will explain to you the difference between base and alkaline, and we will be discussing on physical properties. Then we will be discussing on the uses of acid and alkali in your everyday life. Okay, so let's start. Let's go to the meaning of acid. Okay, let's go to the meaning of acid. What is acid? Okay, so definition for acid is, if you look at your module, definition of acid is a chemical substance. Of course, it's a chemical substance. That's why you learn about acid in chemistry. Okay, so acid is a chemical substance which dissolves in water, or we can say ionizes in water to produce hydrogen ion. This is the most important part. Okay, so acid is a chemical substance which ionizes or dissolves in water to produce hydrogen ion. In fact, hydrogen ion is the one responsible for the properties of acid. Okay, now let's go to, for instance, what do I mean by ionize or dissolves in water? So in order to ionize, it has to dissolve in water. For instance, let's go to nitric acid, HNO3. So when you dissolve in water, what happens is it will ionize to produce hydrogen ion and nitrate ion. Okay, hydrogen ion and nitrate ion. So one thing teacher would like to explain here is this hydrogen ion is actually hydroxonium ion, which you learn in previous chapter, which was in chapter 5. Okay, regarding the dative bond, I was explaining to you about hydroxonium ion. So what happens is when you dissolve nitric acid in water, okay, when you dissolve nitric acid in water, the hydrogen ion actually combines with your water to produce hydroxonium ion. But since we are used to write the hydroxonium because it's still water, so what we do is we write hydrogen as it is, but actually it is actually hydroxonium ion. Okay, but it's okay, you don't need to mention the word hydroxonium, just say acid is a chemical substance which ionizes or dissolves in water to produce hydrogen ion. In fact, this hydrogen ion is responsible to show the properties of acid. Okay, now let's go to the physical properties. What are the physical properties of acid? Okay, as usual, physical properties of acid, it tastes sour, pH lesser than 7. Okay, so these are all the physical properties. Okay, turns blue litmus paper into red. Okay, so these are all physical properties. Okay, corrosive. Okay, corrosive changes blue litmus paper to red, taste sour. Okay, so taste sour and can conduct electricity in aqueous solution. Aqueous means it has with the presence of water. So that is the reason why you can dissolve an acid and you can make it as an electrolyte. You can use it as an electrolyte, okay, for to conduct electricity. Okay, now so let's go to basicity. Now basicity, what is the meaning of basicity? Basicity is the amount of ionizable hydrogen ion when a certain acid is dissolved in water. Okay, so amount of hydrogen ion which can be produced per molecule. Okay, per molecule when you dissolve a certain acid. For instance, hydrochloric acid. For instance, hydrochloric acid. When you dissolve in water, okay, when you dissolve in water, it ionizes to produce one. Just imagine, if this is 1 mole of hydrochloric acid, you will actually produce 1 mole of hydrogen ion and 1 mole of chloride ion. Okay, so 1 mole and this is 1 mole. And this is 1 mole. So this is what we call by basicity, amount of hydrogen ion per molecule which is produced when you ionize it in water. So that is the reason why it has a special name. This hydrogen, this 1 mole hydrogen ion is an example of monoprotic acid. Monoprotic acid. Mono means one. Okay, mono means one. Monoprotic acid. Now let's look at another one example of diprotic acid. Okay, the usual example or popular example is sulfuric acid. Okay, when it ionizes in two, sorry, 2 hydrogen ion, which is literally 2 mole, plus sulfate ion. So can you see you have 2 hydrogen ion here? So since it's 2 hydrogen ion, this is called as diprotic acid. Okay, diprotic, monoprotic acid, diprotic acid. Why? Because it managed to produce, just in case if you dissolve or ionize 1 mole of sulfuric acid, you will find 2 mole of hydrogen is being produced. Okay, now let's go to triprotic acid. Example of triprotic acid is phosphoric acid. Okay, example of triprotic acid is phosphoric acid. Okay, phosphoric acid, where 1 mole of phosphoric acid managed to produce 3 mole of hydrogen ion. So that is the reason why this is the name of this acid is called triprotic acid. Okay, so now in fact when we are learning regarding the strength of acid, acid mana yang paling kuat, okay, strength of acid, you can find, you can easily say that triprotic acid is the strongest acid amongst all these 3 examples that teacher gave you. Okay, imagine hydrochloric acid 1 mole, sulfuric acid 1 mole, phosphoric acid 1 mole. So just by looking at that 1 mole, you know that phosphoric acid is a triprotic acid. So you can say that phosphoric acid is a stronger acid compared to other monoprotic and diprotic acid. Alright? Okay, so let's move on to base. Meaning of base. So when you are in lower form, you were introduced to acid and alkali only. But now we are doing extra introduction of a concept called base. Okay, so base is also a chemical substance. Base is a chemical substance, same like acid. Here it produces, it neutralizes acid to produce water and salt. Okay, so base is a chemical substance which neutralizes acid produce water and water and salt. Okay, water and salt. So this is the meaning of base. Now what is the meaning of acid? But before that, let me give you example of base. Example of base can be magnesium hydroxide. Okay, magnesium oxide, zinc oxide, copper oxide. These are all bases. Okay, so bases which can neutralize acid to produce water and salt. Okay, now let's go to the meaning of alkali. The difference is alkali dissolves in water or ionizes in water to produce hydroxide ion. Can you see the difference? So base, we won't guarantee the production of hydroxide ion. Okay? Why? Because sometimes base, they can't dissolve in water. Okay, that's a problem. Base cannot sometimes dissolve in water, but alkali can. So that is the reason why we use the word dissolves or ionizes in water to produce hydroxide ion. In fact, the property of alkali is actually thanks to the presence of hydroxide ion. Alright? Okay, now so let's go to what are the physical, oh yeah, before that, what are example of alkali? Sodium hydroxide, potassium hydroxide. So these are all usually group 1 metals. Okay, since you've learned about periodic table of elements, group 1 metals are one of the strongest alkalis. That's why we say group 1 metals are alkalis. But group 2 metals sometimes can produce base. Okay, majority of them are base. For instance, calcium oxide, magnesium oxide. Okay, they are bases. Why? Because they cannot dissolve in water. Okay, now let's go to the meaning, not to say meaning, the physical properties of alkali. Physical properties of alkali is taste bitter. Okay, alkali taste bitter. Okay, it tastes bitter, changes red litmus paper changes red litmus paper to blue, slippery, okay, and conducts electricity. In aqueous solution. Okay, now the key, you must dissolve them in water, then they can conduct electricity. Okay, now let's go to uses of acid and base and also alkali. Okay, now so let's go to, before that allow me to give you examples. What happens? Okay, so before that, let me give you examples. When sodium hydroxide is dissolved in water, because teachers say that it produces hydroxide ion. So, for instance, sodium hydroxide or potassium hydroxide, let me use potassium hydroxide. When dissolved in water, it ionizes to produce potassium ion and hydroxide ion. Another example is your ammonia. Okay, so ammonia is actually a weak alkali. Okay, weak alkali which ionizes in water to produce water, because we have water molecule here, same like here, same like here. When dissolves in water, that means you are mixing it in water. Okay, so to produce ammonium ion, remember this is another dative bond. Okay, and hydroxide ion. Okay, so that is the reason why ammonia is considered as a alkali, not base, alkali. Why? Because dissolves in water. In fact, ammonia is a weak alkali, which we will discuss in our later videos. Okay, now so allow me to explain or give you example of uses of sulfuric acid. Okay, so in acid you have quite a lot of uses. First is sulfuric acid. Okay, so one of the highest uses of acid is sulfuric acid. Okay, one is to make detergent, sulfuric acid detergent, fertilizer, thanks to the presence of sulfuric acid. Okay, so thanks to the presence of sulfur, thanks to the presence of sulfur, it is useful to produce fertilizer, detergent, paint, and electrolyte in acid lab accumulator. This is car battery. Okay, so remember teacher said that it can conduct electricity. I think I've told you that it can conduct electricity in aqueous state. Electricity in aqueous state. Okay, so aqueous state. So that is the reason why sulfuric acid mainly used to as a car battery. Second is hydrochloric acid. Okay, second is hydrochloric acid. These are all used widely in our laboratory, chemistry laboratory. Hydrochloric acid. Okay, HCl. Okay, used as a cleansing agent. Okay, because of the presence of chlorine, cleansing agent. Okay, nitric acid. Okay, HNO3. Okay, so used in fertilizer, again thanks to the presence of nitrogen as a fertilizer, and mainly on explosive substances. Okay, plastics and dye, because of the ammonia, the nitrate. Okay, nitrate ion there. Okay, and last one, maybe I give you one example, ethanol, because you see this acid more. Ethanoic acid, or in layman term, okay, so in everyday term, namanya vinegar, cuka. Okay, so vinegar is used, that means you can be eaten lah. Not all, please don't come into a wrong conclusion that chemicals cannot be eaten. Salt is a chemical, sodium chloride is a chemical, but we are eating it every day. So the same concept. Okay, some chemicals can be eaten. For instance, ethanoic acid, alias vinegar, is used in food. Okay, for to prepare food. Okay, and also as preservatives. Okay, so to preserve food, you can use, okay, vinegar. So ethanoic acid is one example, shows the example of everyday uses. Now let's go to base or alkali. Okay, so the first person or the first example is ammonia. N NH3. Okay, ammonia. Okay, NH3 is mainly used as fertilizer. Okay, mainly used as fertilizer to produce nitric acid. Ammonia is used to produce nitric acid. Okay, and also to produce or coagulate, sorry, to decoagulate latex. Decoagulate meaning if the latex has gone hard or coagulated, you can add ammonia to make it become liquid again. Okay, so that is the meaning of coagulate and decoagulate. Coagulate, you make the latex to become hard. Decoagulate, you make the latex to become softer or become in liquid form again. Alright, so another example, calcium hydroxide, very important. This is a base, you don't call alkali, calcium hydroxide. Okay, now, sorry, this is alkali, sorry. Okay, so it is actually to neutralize acidic soil. When the soil has too much of less mineral or something, it will become acidic. And plus, when we use too much of fertilizer, the soil will become acidic. So, in order to neutralize, the concept is to neutralize the soil, we use an alkali, calcium hydroxide. Okay, so another example is magnesium hydroxide. Okay, magnesium hydroxide. Okay, so magnesium hydroxide to make toothpaste and also antacid. This is actually as a one of the mainly used gastric medicine. Okay, mainly used gastric medicine to neutralize excessive acid in the stomach. Okay, so the last one will be maybe I give you sodium hydroxide. Hydroxide. This is also one of the widely used chemical or alkali in the laboratory, sodium hydroxide. Okay, from group 1 metals. So sodium hydroxide, very popular alkali used in laboratory. Okay, so one of the is to make detergent and soap. Okay, to make detergent and soap, we use concentrated potassium hydroxide and sodium hydroxide. Both also can be used in order to produce soap and detergent. Okay, so they just gave you one example here. Alright, so I hope we have covered part 1 for this chapter. Okay, I hope you watch teacher's video and I will see you again in our next part of video. Okay, so thank you for watching teacher's video. See you all again.